Hello and welcome to another Math Monday. Today, you guys see that? It's friggin' fruit flies. How do you get rid of them? Hello and welcome to Math Monday. Where'd it go? Where'd it go? It was right there in front of my face. Hello and welcome to another Math Monday. Today I want to talk more about exponents. I told you guys I could talk about exponents for a very long time. A few weeks ago, I was talking all about exponents and exponent rules, but the only thing is I was only dealing with exponents when they were whole numbers. 1, 2, 3, 4, 5, 6, 7, so on and so forth. So my question is, what if we don't have a whole number in the exponent? What if we have a fraction? So when we're talking about fractional exponents, we're actually talking about something called radicals, which is super rad. I had to. You know I had to. When you have something like 4 to the power of 2 or 4 squared, what is that asking you to do? It's asking you to multiply 4 by 4. So you're multiplying 4 twice, right? So my question is, what happens when you have 4 to the power of something like 1/2? What that's actually asking you is what multiplies by itself to get 4. So what multiplies twice to get 4? That sounds like a really similar definition to what a square root is. That's because it's the same thing as a square root. Can you imagine that? Raising something to the power of 1/2 and square rooting it is exactly the same thing. So when you're trying to square root something, you're trying to figure out what number multiplies by itself to get this number underneath the square root. So that's really just the same as the square root of 4. 4 to the power of 1/2, square root of 4, same thing, and we know it equals 2 because 2 times 2 is equal to 4. So that leads us to one of our most important rules in radicals, or at least the most fundamental one. So something we don't talk a lot about when we write a square root is the fact that there technically should be a 2 between that little check mark thingy of the square root right there, but we never write it because mathematicians are lazy writers, and why would we write more than we have to? And square root is the most typical kind of root that we take, so we don't write the 2 there. So anytime you see a root but without the 2 there, that's just a square root. There's possible things as cube roots and fourth roots and fifth roots, and if you actually see the number written there, it's that kind of root. So when we're writing our most fundamental rule here, we should write the fact that x to the power of 1 over n, n being any natural number, so 1, 2, 3, 4, 5, 6, all the way up to infinity, is equal to the nth root of x. So today we're just going to be looking at when n is 2. So things to the power of 1/2 being the same as the square root of something else. So this is actually really, really important because since radicals are actually just exponents, we can use all those exponent rules that I went over in previous videos for radicals as well, because they're equivalent. Radicals are exponents. Exponents can be radicals. That's fantastic. So there's one specific rule that I went over a few videos ago that I want to use today. I'm not going to go into any of the other rules and how they apply to radicals, just this one, because this is probably the most important thing to be able to do with radicals. And that's the products to a power rule. So if you forget, if I'm multiplying two numbers, or a number and a letter, two variables, a times b, and I raise that to the power of m, that's equivalent to saying a to the power of m times b to the power of m. Okay? So we can do this with a fractional exponent as well. For example, if we had 4x to the power of 1/2. Remember, 4x means 4 times x. So what does that mean? It's 4 to the power of 1/2 times x to the power of 1/2. Now I'm going to switch into radicals because that's really what we want to be working with here. So 4 to the power of 1/2 is the same as the square root of 4. X to the power of 1/2 is the same as the square root of x. So I can just multiply those. And furthermore, I can actually take the square root of 4. We already determined that that's 2 because 4 is 2 times 2. So really what we're going to write this as is 2 times the square root of x. So once we get to this point, we don't even need to write the dot in the middle of the 2 and the square root to signify that they're multiplying. When two things are written together like that and it's a mixture of numbers and letters, we just assume it's always multiplication. So that's 2 root x. Cool. We just used an exponent rule on a radical because it's the same thing. Keep in mind, an equal sign, we don't just have to read it left to right like we do all other English. We can actually read right to left, meaning we can go either way with that rule. So say I had the square root of 3 times the square root of 6. Keep in mind those are exponents because it's 3 to the power of 1/2 times 6 to the power of 1/2. I'm just not writing that anymore because I don't need to. So I can write both of those all with the same exponent, or in this case under the same radical. So that's the same as saying 3 times 6 all square rooted. What's 3 times 6? It's 18. So I just write square root of 18, and that's how I'm going to leave it at this point, because 18 does not square root nicely. There's only certain numbers that square root nicely, and they're perfect squares, like 4, 9, 16, because all those numbers have a number that multiplies by itself to get it, okay? So I'm going to leave it as square root of 18 for now. The only thing about that is that's not actually in simplest form. So once we get into this world of radicals, we get into the world of how we actually should express them if they're not being evaluated, meaning we're not going to write down a number, because if we did, we'd be writing forever because they're irrational numbers. So to know if a radical is in simplest form or not, the base, which is the 18 in this case, we also call that a radicand now that we're working with radicals, can't have a factor that's a perfect square. So what does that mean exactly? Remember, factors are numbers that multiply to get the number. So factors of 18 are 1, because 1 times 18, 2 goes into 18, 3 goes into 18, 6 goes into 18, 9, and 18. All those numbers can divide into 18. So that's how we know they're factors. There's one number there that is a perfect square, and it's that 9. Remember, 9 is 3 times 3. It's a perfect square. So therefore, 18 has a factor that's a perfect square, and the square root of 18 cannot be a radical in simplest form. So what do? We know that 18 is equivalent to 9 times 2. So the square root of 18 is equivalent to the square root of 9 times 2. Due to our rule above, remember, square rooting is the same as raising to the power of 1/2, so I can use that exponent rule, meaning that the square root of 9 times 2 is the same as the square root of 9 times the square root of 2. What's the square root of 9? It's 3. It's a nice whole number, so we just write 3, and that's times the square root of 2. And we write 3 root 2. That is in simplest form, because now once I look at the radicand, the number underneath the radical, it's 2. 2 cannot be square rooted. 2 only has 2 factors, 1 and 2, and you can only square root the 1, but why break that into 1 times 2, because that's not going to change anything. So there we go. That is in simplest form. So in order to simplify radicals like this, you really, really need to know your perfect squares, especially the first 12. So how do you find perfect squares? Well, you just square the numbers from 1 to 12. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. What are the answers to that? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. I'm getting sick of doing this. You guys can do the rest on your own. I'll give you 12 squared. That's 144. So you need to know all the perfect squares automatically from 1 to 144. That needs to be seared into your brain to be able to simplify radicals. That's it for today. I'm sure I could talk about radicals a lot more, and I will in the future. Don't worry. If you'd like me to do a few more examples of how to convert radicals into their simplest form, just let me know. Give me a few suggestions for questions I could do within the comments below. Otherwise, that's it for me on this fine Monday. I hope you guys have just the best week ever.